Today we are going to discuss the derivation of the famous equation of Einstein, E equals mc square. So I hope this is a clear presentation. So here we go. I have looked at a lot of books to find out this derivation of the equation E equals mc square, but I have not found a simple derivation as the derivation that I found in the book by Tony Rothman. It's called Instant Physics by Tony Rothman. So let's start up here. We have a seesaw, and the length of the seesaw is x on this side and x on the other side, and there are two equal masses on each end of the seesaw. Now what's going to happen is some of this mass is going to be transferred to this side in the form of radiation. And when such a thing happens, there is obviously an energy mass transfer to the other side. And so one can consider in that situation the mass on this side would be m plus dm, and on this side would become m minus dm, m of course standing for mass. So coming to this side of the board, when the seesaw is well balanced at the point x0 or x0, xm plus xm equals 0. Now if you solve this equation, taking it for granted that there is an energy mass transfer to the opposite side, then we will get minus x plus dx, which is minus here because this side of the seesaw would be minus and this side of the seesaw would be plus, multiplied by m plus dm plus x plus dx multiplied by m minus dm, because we're going to lose some mass on this side in the form of radiation, and that will again be equal to 0. And if we solve this equation, we get all this. But there are two things that are common, is x dm and mdx are the two entities that do not get cancelled. Therefore we have 2mdx minus 2xdm equals 0. Of course the 2's will cancel off, and then you'll get m dx equals x dm, and let's get x dm on one side of the equation, and so you get x dm equals m upon x multiplied by dx. Now let's move our attention to this side. We know that dx is equal to velocity into time, and we also know that t is equal to 2x divided by the speed of light c. The reason we have taken 2x is because you have 1x on this side and 1x on this side. The distance is 2x. So the radiation would have to travel a distance of 2x at a speed of the velocity of light, which will be c. That will make our dx vt into dx equals v multiplied by 2x upon c. Now if you substitute the value of dx here down here, we will get this v 2x upon c and of course we have m upon x. So mass equals mx in brackets 2x upon c, and that will give us 2 mv upon c. But if you come to this side of the board, we know that 2 mv for this system, which has the length is 2x, is equals 2 mv equals p, which is the momentum. We also know that E, energy, is equal to momentum multiplied by the speed of light, and therefore momentum equals E upon c, energy upon c. And so if you substitute the value of P down here, 2 mv would make it, or 2 mv upon c will make it P upon c. So our dm will become P upon c. But then if you substitute the value P from here, E equals c, then dm would become EC divided by c, and the whole thing is then divided by c again, which will give us E divided by c square. Therefore E equals, and therefore if we keep E on one side of the equation, then E equals delta mc square. Making an approximation, we can say E equals mc square, so E equals mc square. Now this is a very simple derivation with very minimum amount of algebra involved in it. But if you go through Einstein's derivation, it's pretty complicated, and all the other derivations I've seen on the internet, including the YouTube, are also complicated. But this seemed to be a pretty straightforward derivation. Thank you for your attention.